Question 877. Which of the following is the general solution of the differential equation y prime minus 2xy squared is equal to 0? Okay, to find the solution of this differential equation, we have to separate the variable, right? Here y prime is equal to dy over dx is equal to, if we move this term to the right side, that's going to be 2xy squared, right? So separate the variable, y squared goes right here, and 2x times dx goes right here, right? And we're going to integrate each side, right? So antiderivative of 1 over y squared, that's negative 1 over y, is equal to antiderivative of 2x, that's x squared, plus c, right? We always have to add c after we find the antiderivative on the right hand side, right? Now, we have to solve for y in terms of x and c. So 1 over y is equal to, if we multiply negative each side, that's negative x squared plus c, right? Because the c times negative 1 is just another constant c, okay? Well, c times constant 2, that's a constant c. C divided by, let's say, 5, that's another constant c, right? So 1 over y is equal to negative x squared plus c. So that is equal to y is equal to 1 over negative x squared plus c, right? Or we can write 1 over c minus x squared. So the answer is B. Okay? Question 880. Write the particular solution of the differential equation dy over dx is equal to 2y plus 1 with the initial condition 3, 0. Okay, the first thing we have to do is we have to separate the variable in this differential equation, right? Since we have dy over dx is equal to 2y plus 1, well, 2y plus 1 can be written as 2y plus 1 times 1, right? So we're going to multiply dx each side. Then that's going to be dy is equal to 2y plus 1 times dx. And move this term to the left side. Then that's going to be equal to dy over 2y plus 1 is equal to dx, right? Now we're going to differentiate each side. The antiderivative of 1 over 2y plus 1 on the left hand side, that's 1/2 times natural log 2y plus 1, right? On the right hand side, that's going to be x plus c, right? If you are confused with this part right here, the antiderivative of 1 over 2y plus 1, you can use substitution. So here we have integral 1 over 2y plus 1 dy. We're going to let u be 2y plus 1. Then our du is equal to, as you see it, u is the equation in terms of y, right? So if we differentiate this equation with respect to y, du over dy is equal to 2, then du is equal to 2 times dy, right? Does that make sense? Okay, so in order to have du, we must have 2 times dy. So we're going to multiply 2 here. Then we have 2 divided by 2 here, right? So that is equal to 1/2 integral 1 over u du. So that's 1/2 natural log u, right? It's equal to 1/2 natural log u is 2y plus 1, right? That's why we have this antiderivative from 1 over 2y plus 1. So far so good. So here we have 1/2 times the natural log 2y plus 1. So we're going to multiply by 2 each side. So natural log 2y plus 1 is equal to 2x. 2 times the c is just the constant c, right? Now, we're going to have to find the value of c by substituting 3 for x and 0 for y, since the graph of y passes through this point right here. So when x is 3, y is equal to 0, right? So natural log 1 is equal to 6 plus c. Natural log 1 is equal to 0, right? So c is equal to -6, right? So this value is -6. So we have the equation that's log 2y plus 1 is equal to 2x minus c. Then if we solve for y, 2y plus 1 is equal to, using the definition of logarithm, that's e to the power of 2x minus 6, right? So 2y is equal to e to the 2x minus 6 minus 1. So what is y? Here, let me write right over here. Y, the solution y is equal to e to the 2x minus 6 minus 1 over 2. That's our particular solution to this differential equation, right? Question 887. On the graph of y is equal to h over x, the slope at any point x, y is y over 1 plus x squared. If h of 0 is e, then what is the value of h of 1? Okay, since the slope of this graph is y over 1 plus x squared, we have dy over dx is equal to y over 1 plus x squared, right? Because the dy over dx is the slope of the curve. Now we're going to have to separate the variable. So we have dy over y is equal to dx over 1 plus x squared, right? Now integrate each side. So far so good. What's antiderivative of 1 over y? That's natural log y. We all know that. And that is equal to antiderivative of 1 over 1 plus x squared. That's inverse tangent, right? And we have to add constant c. Remember, the derivative of inverse tangent x is equal to 1 over 1 plus x squared, right? So the antiderivative of 1 over 1 plus x squared is inverse tangent x, right? Now, when x is equal to 0, y is equal to e. So we're going to substitute 0 here, e here. Then we have a natural log e, which is equal to 1, is equal to inverse tangent 0. That's 0, right? Because the tangent of 0 equal to 0. So 0 plus c. So we know that c is equal to 1, right? So we have natural log y is equal to inverse tangent x plus 1, right? Then what is y? Y is e to the inverse tangent x plus 1. And the question is, what is value of y when x is equal to 1, right? So let's rewrite the function right here. Inverse tangent x plus 1. When x is equal to 1, what is the value of y? So y of 1 is equal to e to the inverse tangent 1 plus 1. What's inverse tangent 1? Right here. Tangent of what angle gives us 1? That's pi over 4, right? So that is equal to e to the pi over 4 plus 1, right? So this is our answer. Question 900. For the differential equation, dy over dx is equal to natural log y squared minus 2x plus 1 with the initial condition y of 1 is equal to, does the solution curve have a relative minimum or a relative maximum or neither at x equal 1? Okay, when x is equal to 1, our y is 2, right? And at this point, our first derivative is equal to natural log 2 squared minus 2 times 1 plus 1, right? So that's going to be 4 minus 2 plus 1, that's 1, right? So the natural log 1, which is equal to 0, right? Our first derivative at 1, 2 is equal to 0. What about our second derivative? Okay, our second derivative is equal to, we're going to have to differentiate this equation, right? So that's 1 over y squared minus 2x plus 1 times the derivative of y squared minus 2x plus 1, right? So the derivative of that is power of 2y times the derivative of y, which is equal to dy over dx, minus the derivative of 2x, that's 2, the derivative of 1, that's a 0, right? That's our second derivative. So our second derivative at the point 1, 2 is equal to, okay, substitute 1 for x, 2 for y. So 2 squared minus 2 times 1 plus 1 times 2 times y is equal to 2. And dy over dx at this point, 1, 2 is equal to 0, right? So times 0 minus 2. So that's going to be negative 2 over 4 minus 2 plus 1, that's 1. So negative 2, right? So our first derivative is equal to 0, and our second derivative at the point 1, 2 is negative 2, right? If we have y prime is equal to 0 and y double prime is negative at the point 1, 2, then we know that y has relative maximum at the point by the second derivative test, right? So we have relative maximum at this point. Question 903. Consider this differential equation right here. If y is equal to f is the particular solution to the differential equation with f of 1 is equal to 0, what is the value of this limit? Okay, we have to find this limit as x approaches 1, right? So if we substitute 1 for x, then that's going to be equal to f of 1, which is equal to 0, over 2 minus 4 plus 2. That's 0, right? So numerator is equal to 0, denominator is equal to 0. Then we're going to have to apply the L'Hopital's rule, right? Let's erase all this. And we're going to apply the L'Hopital's rule. So equal to, the derivative of f is just the f prime, right? F prime of x. And the derivative of the denominator, that's going to be 4x minus 4, right? Here, f prime is given right over here, dy over dx. It's 1 minus e to the xy squared minus x plus 1. So I'm going to substitute 1 minus e to the xy squared minus x plus 1 for f prime of x. And denominator, we have a 4x minus 4, right? Now, let's substitute 1 for x. So if we substitute 1 for x, denominator will be equal to 0, right? Here, 1 for x. When x is equal to 1, y is equal to 0, right? So 0 for y, 1 for x. Then that's going to be equal to 1 minus e to the 0 minus 1 plus 1. So that's 1 minus e to the 0. 1 minus 1. So that's 0, right? Again, if we substitute 1 for x and 0 for y, the numerator will be equal to 0 and denominator is equal to 0, right? So we're going to have to apply the L'Hopital's rule one more time. Okay, I'm going to erase this. Okay, by applying L'Hopital's rule one more time, we have limit as x approaches 1. Numerator, derivative of 1 is equal to 0, right? So derivative of exponential function, that's negative e to the xy squared minus x plus 1 times derivative of this expression right here. We're going to have to apply the product rule for this, right? So that's going to be derivative of x, 1, y squared plus x, derivative of y squared, that's power chain, right? Minus derivative of x, that's 1, right? Now, derivative of 4x minus 4, that's just the 4, right? Now, let's substitute 1 for x and 0 for y. So, 1 here, 0 here, 1 here, 0, 1, 0. So, that's going to be equal to, denominator is just the 4, numerator, here negative e to the negative 1 plus 1, 0, right? Times, here we have 0 plus 1 times 2 times 0 again. And dy over dx is also 0, right? Minus 1. So that's going to be equal to negative 1 times negative 1 over 4. So that's 1 over 4, right? So our final answer, the limit of this expression is equal to 1 over 4, right? Question 907. Consider the differential equation dy over dx is equal to 8x minus 4y minus 5. What is the value of k plus m if y is equal to kx minus m is a solution to the differential equation? K and m are constants. Alright, it says y is equal to kx minus m is a solution to this differential equation, right? So this y here is equal to kx minus m, and dy over dx is a derivative of this solution y, right? Here, derivative of y, which is equal to dy over dx, is equal to the derivative of kx minus m is just the k, right? So I'm going to substitute k for this dy over dx, right? Okay. K is equal to 8x minus 4y, and our y is kx minus m, right? So 4 times kx minus m minus 5, right? So k is equal to 8x minus 4kx plus 4m minus 5. Here we have 2 x terms, 2 constants, right? On the left hand side, we only have constant k, right? So this equation can be written as k is equal to, if we factor x, that's going to be 8 minus 4k times x plus 4m minus 5, right? The expression on the left hand side is equal to the expression on the right hand side when a minus 4k is equal to 0, right? Number 1, a minus 4k must be equal to 0. Number 2, here we have constant k on the left hand side, constant 4m minus 5 on the right hand side. So k must be equal to 4m minus 5, right? So 8 is equal to 4k, then k is equal to, right? Now substitute 2 for k here, and then we have 2 is equal to 4m minus 5, 7 is equal to 4m, so m is equal to 7 over 4, right? So finally, what is the value of k plus m? K plus m is equal to 2 plus 7 over 4. Since 2 is 8 over 4, k plus m is equal to 15 over 4. That's our answer, right?